Imagine stepping into a time machine, not to visit ancient Egypt or the Roman Empire, but to witness a moment far more unsettling, a world before history, before cities, before language as we know it. You arrive nearly 200,000 years ago. The air is hot and heavy. Insects hum in the distance. The scent of smoke drifts through the wind. And then you see them. The first Homo sapiens. They move, they hunt, they survive. At first, nothing seems extraordinary. Then you notice something unexpected. Their appearance challenges everything you imagined about the first humans. And suddenly, one question takes over. What did humanity originally look like before it spread across the world? Here's the twist most people never consider. Had early humans never left Africa, every person alive today would most likely still have dark skin, which means the diversity we see today wasn't humanity's starting point. It was the result of something that changed. But what could reshape something as visible as skin? Most people assume it was simply time. Yet, if that were true, human appearance would have changed randomly. Instead, clear patterns emerged. Patterns linked to geography. The answer begins with something every one of us experiences every single day. Sunlight. As humans spread into new environments, different levels of ultraviolet radiation quietly shape their bodies over thousands of generations. Your skin is not random. It's a biological record of where your ancestors survived, and before sunlight could ever reshape humanity. One question still remains. What did the very first human skin have to be before any of that change was even possible? The first humans didn't have dark skin because evolution designed it for appearance. They had it because without it, many simply wouldn't have survived. For hundreds of thousands of years, our ancestors lived beneath the intense African sun. Near the equator, ultraviolet radiation wasn't just sunlight. It was an invisible force, quietly damaging cells and threatening the body's ability to function and reproduce. Humanity needed protection. Evolution found one. Not thicker skin, not more body hair, a microscopic pigment, melanin. Melanin's true purpose has nothing to do with appearance. It is humanity's original survival technology, a natural shield that absorbs harmful ultraviolet radiation before it can damage DNA or interfere with essential biological processes. But the greatest danger wasn't just damaged cells. It was something hidden. The loss of a vital nutrient called folate, which unborn babies need for healthy development. Without enough folate, pregnancies were far more likely to fail. Behind that reality were real families, never knowing why some children survived while others didn't. Those with more melanin were more likely to raise healthy children, who inherited the same protective advantage. Generation after generation, dark skin became humanity's most successful adaptation beneath the equatorial sun. But evolution never stands still. Eventually, small groups of humans left Africa, crossing deserts, coastlines, and mountains into lands where sunlight was far weaker. With every step north, the environment changed, and so did the rules of survival. The very adaptation that once protected humanity was about to face an entirely different world. Around 60,000 to 80,000 years ago, humanity began one of the greatest journeys in its history. Small groups left Africa. No maps, no roads, no idea what waited beyond the horizon. Yet they kept walking, generation after generation, unknowingly spreading across an entire planet. Some reached the Middle East, others crossed Asia. Eventually, humans settled Europe, Siberia, Australia, and even the Americas. But with every step away from the equator, something invisible began to change. The sunlight. At first, weaker sunlight seemed like an advantage. Less ultraviolet radiation meant less damage. Problem solved. Except the sun wasn't only a threat, it was also essential. Without enough ultraviolet light, the body struggles to produce vitamin D, a nutrient critical for healthy bones, growth, and the immune system. Children began to suffer long before anyone understood why. In Africa, abundant sunlight allowed dark skin to protect the body while still producing enough vitamin D. Farther north, that balance disappeared. Ironically, the same skin that once protected life now made survival more difficult. Over thousands of generations, people with slightly lighter skin produced vitamin D more efficiently beneath dimmer skies, giving them a small but important survival advantage. Evolution wasn't making humans better, it was making them better suited to a new environment. And those tiny changes, repeated across countless generations, slowly transformed entire populations. But the first humans who entered Europe didn't look like the Europeans living there today. Ancient DNA reveals a far more surprising story. When people imagine the first humans arriving in Europe, they often picture them looking much like modern Europeans, but that assumption doesn't hold up. Ancient DNA has completely changed the picture. By studying prehistoric skeletons, scientists discovered that some of Europe's earliest hunter-gatherers likely had a combination of traits that seems almost impossible today. Dark skin, blue eyes, and dark hair. A face that challenges everything we thought we knew. Evolution doesn't build types of people. It responds to survival one trait at a time. Lighter skin didn't appear overnight. It spread slowly across thousands of years as different genetic mutations became more common. Then another force reshaped the story. Farming, as people relied more on crops and less on wild animals. Many diets contained less vitamin D, giving an advantage to skin that could produce it more efficiently beneath weaker northern sunlight. But diet wasn't the whole story. Migration transformed Europe again and again. Every movement brought together populations that had evolved separately for thousands of years, mixing genetic variations in entirely new ways. Some traits spread, others faded. Many blended together across countless generations. There was never a single moment when Europe turned white. Instead, the continent was gradually reshaped by climate, diet, migration, and chance. Evolution doesn't behave like a switch. It behaves like a river delta, constantly branching and merging into new paths. And Europe was only one chapter. Far to the east, another population faced the same challenge of weaker sunlight, yet reached a similar destination through a completely different genetic journey. What does that reveal about the remarkable ways human diversity evolved? Imagine giving two engineers the exact same challenge and watching them build two completely different machines that accomplish the same task. That's surprisingly close to what evolution did. Both Europeans and East Asians eventually developed lighter skin than their African ancestors, but they didn't get there through the same genetic changes. Take a moment to think about that. Two populations separated by geography and time faced the same environmental challenge. Yet evolution wrote two different biological solutions into their DNA. The destination looked similar. The evolutionary paths did not. Scientists have discovered that many of the genes linked to lighter skin in European populations are different from those that became common in East Asian populations. Evolution didn't reuse a single blueprint. It solved the same problem twice. And that changes how we should think about human diversity. Biology doesn't work in boxes. It works in gradients. Human skin color isn't divided into separate groups. It's a continuous spectrum shaped by climate, geography, migration, and thousands of years of genetic mixing. Communities living beneath intense tropical sunlight generally retain darker pigmentation, while populations in regions with weaker ultraviolet light gradually evolved lighter skin. Between those extremes lies an enormous range of adaptations, each reflecting a unique evolutionary history. That's why appearance doesn't always match ancestry as neatly as we imagine. The deeper scientists study our DNA, the clearer the pattern becomes. Every shade of human skin tells the story of populations adapting to their environment. Different paths, different genes, but beneath it all, the same shared human journey. Let's go back to where this story began. Picture one of the first Homo sapiens standing beneath the African sun nearly 200,000 years ago. They had no idea their descendants would one day live on every continent. They couldn't imagine cities, airplanes, or satellites orbiting Earth. They were simply trying to survive, yet hidden within their future descendants was every skin tone that exists today. The darkest complexions, the lightest, and every shade in between. As humans spread into new environments, adaptation quietly shaped each population, not through intention, not through design, but through survival. No group became more human than another. They simply became better suited to the places they called home. And after everything we've explored, one fact is almost impossible to comprehend. More than 99% of our DNA is shared. The visible differences we notice, first, are built upon an overwhelming foundation of biological sameness. In evolutionary terms, our differences are remarkably young. Our shared ancestry is ancient. So what color were the first humans? Almost certainly dark-skinned. But that's not the end of the story. It's the beginning. Every complexion on Earth, from the deepest brown to the palest ivory, is part of the same human journey. A journey that began beneath one African sky, with one species, one common origin, and one human family gradually spreading across a changing world. The next time you look in the mirror, pause. You're not just seeing your own face. You're seeing a living record of a story that began hundreds of thousands of years ago.